Question 1. A sterile processing technician is reviewing the environmental controls for a room housing an ethylene oxide, EO, sterilizer. To meet safety regulations and protect staff from fugitive gas, what is the minimum required ventilation rate for this specific area? A. 4 air exchanges per hour under positive pressure. B. 10 air exchanges per hour under positive pressure. C. 10 air exchanges per hour under negative pressure. D. 2 air exchanges per hour under neutral pressure. Correct answer C. Knowledge point explanation. Core rationale. The Occupational Safety and Health Administration, OSHA, mandates strict environmental controls for areas using highly toxic chemicals like ethylene oxide. The room must maintain negative pressure to prevent gas from drifting into adjacent areas, and it must have at least 10 air exchanges per hour to rapidly exhaust any potential leaks and protect the technician's health. Trap analysis. Option A is incorrect because 4 air exchanges per hour under positive pressure is the standard for a sterile storage area, not a hazardous gas room. Option B is incorrect because positive pressure would push toxic fumes out into the main department, endangering other staff. Option D is incorrect because 2 air exchanges per hour is meant for administrative or public areas. Concept extension. Always associate negative pressure and high air exchange rates, 10 ACH, with the decontamination area and the EO sterilizer room, as both contain hazardous elements, bioburden and toxic gas, respectively, that must be contained and exhausted outdoors. Question 2. Modern low-temperature sterilization methods utilizing ethylene oxide, EO, typically deliver the chemical sterilant into the sealed chamber through which of the following mechanisms? A. Bulk liquid tanks pumped directly into the machine. B. Single-dose gas cartridges punctured inside the chamber. C. Pre-mixed chemical powders dissolved in water. D. Vaporized liquid solutions introduced via a vacuum system. Correct answer B. Knowledge point explanation. Core rationale. To minimize the risk of massive chemical spills and exposure, modern ethylene oxide sterilization equipment utilizes single-dose gas cartridges containing 100% EO. These cartridges are placed inside the chamber with the load and are automatically punctured only after the door is sealed and a vacuum is drawn. Trap analysis. Option A is incorrect because bulk tanks present an extreme occupational hazard and are largely obsolete in modern hospital settings. Option C is incorrect as EO is a gas, not a powder. Option D describes the delivery method for hydrogen peroxide vapor systems, not EO. Concept extension. The shift to single-dose cartridges significantly reduced the frequency of OSHA violations related to fugitive EO gas emissions in healthcare facilities. Question 3. Which of the following terms describes the calculated probability of a viable microorganism being present on a medical device after it has completed a sterilization cycle? A. Time-weighted average. B. Bioburden reduction value. C. Permissible exposure limit. D. Sterility assurance level. Correct answer D. Knowledge point explanation. Core rationale. The sterility assurance level, SAL, is the mathematical probability of a single viable microorganism occurring on an item after sterilization. For critical medical devices, the standard requirement is an SAL of 10 to the negative 6th power, representing a 1 in a million chance of non-sterility. Trap analysis. Option A is incorrect because time-weighted average, TWA, relates to occupational exposure calculations over an 8-hour shift. Option B is a fabricated distractor regarding the cleaning phase. Option C is incorrect as the permissible exposure limit, PEL, defines the maximum legal limit for staff exposure to hazardous chemicals. Concept extension. Because absolute sterility cannot be proven without destroying the item in testing, the industry relies on achieving the required SAL through validated and monitored sterilization parameters. Question 4. While preparing to run a mixed load of delicate microsurgical instruments in an ethylene oxide, EO, sterilizer, the technician must select the appropriate biological indicator. Which specific bacterial spore is required to verify the lethality of this cycle? A. Geobacillus styrothermophilus. B. Bacillus atrophius. C. Pseudomonas aeruginosa. D. Staphylococcus aureus. Correct answer B. Knowledge point explanation. Core rationale. Biological indicators test the lethality of a sterilizer by challenging it with highly resistant spores. For ethylene oxide, EO, and dry heat sterilization, Bacillus atrophius is the designated organism because it demonstrates exceptional resistance to these specific killing methods. Trap analysis. Option A is incorrect. Geobacillus styrothermophilus is exclusively used to monitor steam, hydrogen peroxide, and ozone processes due to its heat and oxidation resistance. Options C and D are common vegetative pathogens, not highly resistant spores, and are easily destroyed by basic disinfection, making them entirely useless for verifying sterilization. Concept extension. The Latin prefix atro- means dark, referring to the dark colonies this organism forms. Always remember the A in atrophius stands for air/gas, EO, to differentiate it from Geobacillus. Question 5. During an 8-hour shift operating the ethylene oxide, EO, sterilizer, a technician is required to wear a personal monitoring device to track chemical exposure. Where must this dosimeter badge be affixed to ensure accurate measurements? A. Attached to the wall directly above the sterilizer exhaust. B. Clipped directly to the employee's clothing within their breathing zone. C. Placed inside the sterilizer chamber during the cycle. D. Fastened to the transfer cart used to move the aerated load. Correct answer B. Knowledge point explanation. Core rationale. Personal monitoring for hazardous chemicals requires capturing the actual air inhaled by the worker. Therefore, regulations state the device must be affixed to the employee's clothing within their breathing zone, typically defined as a 1-foot radius around the nose and mouth. Trap analysis. Option A describes area monitoring, not personal monitoring. Option C would result in the badge being destroyed or maxed out by the 100% EO concentration inside the machine. Option D measures the cart's environment, not the continuous moving environment of the specific technician. Concept extension. The data collected from this badge is used by occupational health professionals to calculate the technician's time-weighted average, TWA, to ensure it does not exceed the permissible exposure limit, PL, of 1.0 ppm. Question 6. A technician is monitoring a legacy ethylene oxide, EO, sterilizer. After the active gas exposure and the exhaust stages are fully complete, the machine transitions into the next mandatory phase to ensure the surgical load is safe to handle. What is this immediate next step called? A. Preconditioning. B. Alkylation. C. Aeration. D. Desiccation. Correct answer C. Knowledge point explanation. Core rationale. In an ethylene oxide sterilization cycle, the aeration phase is a critical safety step that immediately follows the gas exhaust phase. It utilizes HEPA-filtered warm air to actively flush and remove highly toxic residual gas that has been absorbed by the packaged instruments. Trap analysis. Option A is incorrect because preconditioning, adding heat and humidity, is the very first phase of the cycle before gas is introduced. Option B is incorrect because alkylation is the chemical mechanism by which the gas kills microorganisms, not the name of a machine phase. Option D is incorrect because desiccation means drying out the spores, which actually makes them highly resistant to the gas and causes cycle failure. Concept extension. Items must never be removed from the chamber until the full aeration time, e.g., 8 hours at 140 degrees Fahrenheit or 12 hours at 122 degrees Fahrenheit, is complete to prevent severe chemical burns to staff and patients. Question 7. A sterile processing department is validating a newly installed low-temperature hydrogen peroxide vapor sterilizer. The quality assurance protocol requires running a biological test pack. Which specific microorganism must the technician select for this test? A. Bacillus atrophius. B. Geobacillus stereothermophilus. C. Mycobacterium tuberculosis. D. Clostridium difficile. Correct answer B. Knowledge point explanation. Core rationale. Geobacillus stereothermophilus is the designated biological indicator for monitoring hydrogen peroxide, ozone, and steam sterilization processes. The spores of this specific organism demonstrate exceptionally high resistance to oxidation and extreme heat, making them the ideal challenge for these cycles. Trap analysis. Option A is incorrect because Bacillus atrophius is exclusively used to test the effectiveness of ethylene oxide gas and dry heat sterilization. Options C and D are incorrect as they are pathogenic bacteria, not the highly resistant standardized spores required to scientifically validate a sterilization cycle. Concept extension. While hydrogen peroxide cycles are much faster than ethylene oxide, performing biological monitoring remains a critical daily requirement to ensure the oxidation process successfully reached all items. Question 8. While the precise parameters of low-temperature sterilization cycles can vary based on the specific machine model and the density of the load, what is a standard representative active gas exposure time for an ethylene oxide, EO, sterilization cycle? A. 28 minutes. B. 75 minutes. C. 2.5 hours. D. 12 hours. Correct answer C. Knowledge point explanation. Core rationale. Unlike rapid steam or hydrogen peroxide cycles, ethylene oxide operates at very low temperatures, typically between 98 to 145 degrees Fahrenheit. Because the chemical alkylation reaction occurs slowly at these low temperatures, the active exposure phase where items sit in the sterilant gas requires several hours, with 2.5 hours being a widely recognized representative benchmark. Trap analysis. Options A and B are incorrect because 28 to 75 minutes represents the typical total cycle time for modern, rapid hydrogen peroxide gas plasma systems. Option D is incorrect because 12 hours refers to the lengthy aeration time required at lower temperatures, not the active gas exposure time. Concept extension. The combination of long exposure times and extensive aeration periods is the primary reason ethylene oxide has the slowest turnaround time in the sterile processing department. Question 9. During an annual safety audit, the department manager reviews the environmental monitoring logs for the chemical sterilization area. Which federal agency is legally responsible for establishing the maximum permissible exposure limits for the technicians working with these chemical sterilants? A. The U.S. Food and Drug Administration, FDA. B. The Environmental Protection Agency, EPA. C. The Occupational Safety and Health Administration, OSHA. D. The Centers for Disease Control and Prevention, CDC. Correct answer C. Knowledge point explanation. Core rationale. The Occupational Safety and Health Administration, OSHA, is the federal agency strictly dedicated to workplace safety. It establishes legally binding standards, such as the Permissible Exposure Limit, PEL, which dictates the maximum amount of toxic chemical vapor a worker can safely be exposed to over an 8-hour shift. Trap analysis. Option A is incorrect because the FDA regulates the manufacturing and marketing of the sterilizers and chemicals, not worker safety. Option B is incorrect because the EPA regulates the emission of these chemicals into the outside environment, air and water. Option D is incorrect because the CDC issues infection control guidelines but does not enforce occupational exposure laws. Concept extension. Facility compliance with OSHA regulations is verified through mandatory personal and area monitoring systems near low-temperature sterilizers. Question 10. Before a chemical manufacturer can legally market a new low-temperature liquid sterilant or gas cartridge to healthcare facilities, the product must undergo rigorous testing and clearance. Which federal agency is responsible for enforcing this pre-market approval requirement? A. The U.S. Food and Drug Administration, FDA. B. The Occupational Safety and Health Administration, OSHA. C. The Environmental Protection Agency, EPA. D. The Association for the Advancement of Medical Instrumentation, AAMI. Correct answer A. Knowledge point explanation. Core rationale. The U.S. Food and Drug Administration, FDA, treats low-temperature sterilizers and their chemical sterilants as Class II medical devices. Therefore, the FDA strictly requires manufacturers to provide scientific proof of efficacy and safety through a 510(k) pre-market clearance process before the product can be legally sold to hospitals. Trap analysis. Option B is incorrect as OSHA enforces worker safety protocols within the hospital, not product market clearance. Option C is incorrect. While the EPA regulates environmental disinfectants, sterilants used on critical medical devices fall under FDA jurisdiction. Option D is incorrect because AAMI creates comprehensive voluntary standards and guidelines for sterile processing practices but has no federal regulatory authority to approve products. Concept extension. This rigorous FDA oversight ensures that any chemical agent used in the sterile processing department will reliably achieve the required sterility assurance level without damaging the medical instruments.